I think we have a treat in store for us. Marcia McNutt is the president and chief executive officer of the Monterey Bay Aquarium Research Institute. You call it MBARI? MBARI, yeah, that's the name. In California, a nonprofit research lab funded by the Packard Foundation to develop and apply new technology for the exploration of the oceans. She was born in Minneapolis, which I think is near Minnesota, graduating class valedictorian, a succession of academic honors, and a PhD from the Scripps Institute of Oceanography in La Jolla, California. 15 years at MIT, senior professor. She was a Griswold Professor of Geophysics and director of the Joint Program in Oceanography and Applied Ocean Science and Engineering. In 1988, she won the McElwain Award from the American Geophysical Union, presented for outstanding research by a young scientist. In 1997, she left MIT to take over leadership of MBARI. She just completed her term as president of the American Geophysical Union and chaired the President's Panel on Ocean Exploration. She's been elected membership to both the American Academy of Arts and Sciences and the American Philosophical Society. In one of the many items I found on internet, someone said she sees science as a jigsaw puzzle, a giant jigsaw puzzle, and then said, when the pieces all fit together, it's so much fun. Her research involves using ocean geophysical data for a study of the physical properties of the Earth beneath the oceans. To collect data, as head of MBARI, she is responsible for designing and building new underwater vehicles for sampling of information on the ocean bottom and its inhabitants. So without further ado, I'll present Marcia McNutt, who will talk about engineering the ocean.
Thank you so much, Dr. Letterman, for that introduction. I know that it may seem strange to many of you that here an oceanographer would come to Illinois to talk about the sea, but if you think about it, the ocean affects your lives, and what you do with your lives affects the oceans. Now, you're fortunate to have here the Shedd Aquarium, and I hope you all take the opportunity to visit it, because we're realizing more and more that all citizens of this country, in fact, all citizens on the globe, really need to understand more their connection with the ocean and the ocean's connection with them. Tonight, I'd like to speak on a topic called engineering the ocean. And the reason I'd like to speak on this is it's because our future does hinge on a better understanding of the complex living ocean. The ocean is not just a physical being, it's a living organism. In every drop of seawater, there are 1,000 bacteria and 10,000 viruses, most of whom we have not identified and don't even know what they're doing. We know that the ocean is the lifeblood of our planet. And here's just a list of some of the reasons why the ocean is important. For example, there are no known examples of life in the universe, to date anyway, that don't require liquid water for survival. The reason Earth teems with life is because it is the ocean planet. The ocean also has vast capacity for heat storage, and because of its heat storage, it can carry solar energy from the equator, where it's most plentiful, towards the poles. And in that way, it keeps more of the Earth ice-free and therefore more of the Earth inhabitable than would be possible if we only had to rely on atmospheric heat transport. The ocean provides all sorts of natural ecosystem services, such as cycling nutrients and waste treatment, carbon storage, etc. Some people don't understand that actually most of the photosynthesis that occurs on Earth actually occurs in the ocean by microscopic plants that live in the upper few meters of the ocean. The bounty of the seas also provides an inexpensive source of protein, which feeds most of Earth's human population in terms of those who live near the sea. And the ocean right now provides the principal highway for commerce. most goods are carried by the ocean at one point or another in their transportation from their producer to their consumer. And approximately 20% of our supply of fossil fuels is derived from reservoirs beneath the continental margins. Now what I'd like you to do is imagine what life might be like on the planet in the year 2025. That's about the time that the students here in this audience will be finished with college and have risen to leadership positions in science, in technology, in government, in public policy, and in industry. Now, in that year 2025, I would predict that through intense efforts in public education, that the human birth rate will have stabilized. But even if we stabilize the birth rate, the human population will still be growing, and that is because life expectancy will increase. 75% of the Earth's population in the year 2025 will be concentrated along the coastal plains of the continents, and that will cause mounting costs to governments in terms of disaster relief from more frequent hurricanes, more frequent severe storms, and rising sea level, all exacerbated by global warming. Scientists will be under increasing pressure to better predict and even mitigate some of these natural disasters. Now, we will propose that in the year 2025, that modern agricultural practices will have been extended to all countries on the globe. Harvests will be maximized, but the population, much of the population, will still go hungry because we will have maxed out the possibility of land to supply our need for food. So the only hope for increasing food production will be to turn to the ocean. But in turning to the ocean, we know that the international agreements on who owns the ocean and therefore who can manage the ocean will be far from finalized. I am guessing that all citizens of the 21st century are going to want electricity and they're going to want to have powered vehicles. But energy will be very expensive on account of the dwindling supply of fossil fuels and on account of the mounting costs for carbon recovery to mitigate the release of carbon to the atmosphere, which causes global warming. So action will need to be taken, and the oceans are the only remaining source of untapped potential on this planet. Now, we know that human exploitation of the land is rife with examples of environmentally damaging practices. There are many cases in which mitigation of the damage was costly, time-consuming, and in some cases even impossible. So the question is, will we have learned our lesson on land, and can we do any better with the ocean? Now, to illustrate these ideas, what I'd like to do is now take you on a series of 5 future scenarios of how mankind might purposely intervene in the oceans to use it or misuse the ocean research for mankind's benefit. Now, I'll ask the students here to consider what are the economic, political, environmental, and moral choices that we will face, and ask yourselves how you can best prepare yourselves as citizens of the 21st century to make the choices. Okay, my first future scenario I'm calling Climate's Down Escalator. Okay, this is a picture of Argo floats. These floats exist. They've been deployed in the oceans by the thousands at this time. And these low-cost drifters have already begun to endlessly circle the globe, passengers on the great currents that transport heat from the equator towards the poles. And as they move along on these ocean currents, they transmit back to shoreside labs information on the temperature of the ocean, on the current velocities, and other important physical oceanographic factors. Now, what we know, as is shown here, what did I do? On this diagram, this red-green ribbon is called the Great Conveyor Belt. And the Great Conveyor Belt is simply one part of the global circulation system, but it's a very important one. On this conveyor belt, water that is warmed in the tropics is carried poleward, and as it goes up towards the North Atlantic, because evaporation there exceeds precipitation, the water becomes more and more saline, and because and colder and colder. And as it becomes more saline, it becomes denser, and finally in the northernmost Atlantic, it sinks. And as it sinks, it then returns back to the south, but its sinking continues to drive the northward migration of this great current, in a sense sucking heat up towards the pole and keeping it warm. Now, imagine that these drifters in the year 2025 have spent more than 2 decades riding these currents. Now, the relay of data from the currents is direct whenever the drifter's at the surface, and when it's under the water, it sends up a little messenger that phones home and gives its data back to central processing facility. Now, in the central processing facility, in the year 2025, we will have computers large enough that they will be able to assimilate all this data in order to infer what changes in circulation are required by changes in temperature and the salinity of the water. These data will be combined with meteorological data and immediately integrated into a massive global ocean model that predicts the weather of the ocean, much like we predict the weather of the air around us at this time. The models can be run forward in a forward mode to predict forecasts. And these forecasts will be useful for shipping companies, for naval operations, and for the growing number of multinational companies that have commercial operations in the oceans. Now, the accuracy of these forecasts, just like the weather forecasts, gets worse and worse as one goes out further in time, but advances in understanding of complex nonlinear systems, along with the existence of better data to assimilate into these models, results in fairly reliable forecasts for a period of a week or more. In addition to providing these ocean forecasts, the output from the models can be integrated even further into the future to provide estimates of ocean climate for a year or more in advance. These are useful for predicting overall heating and cooling of the ocean and major changes in poleward heat transport. This information will be vital to farmers in deciding what crops to plant based on projections of temperature and rainfall from the ocean climate model. So in the year 2025, much of the guesswork in the global commodities market will have disappeared once the global ocean climate forecasts are routine. But now let's suppose that we get to the year 2025. This is a map of wind speed. And let's suppose this map for 2025 suddenly picks up some wind anomalies in the Indian Ocean. Abnormal wind patterns in the Indian Ocean cause a substantial deepening of the thermocline, or the thickness of the warm surface ocean layer in that part of the ocean. By moving these environmental forecasts into the future, the computer predicts that this situation will lead to a massive El Nino, potentially the most extreme event of its kind ever recorded. Even more worrisome is a forward projection of the climate model predicts that the warm El Nino will lead to an unusually warm winter and summer in the northeast Atlantic, causing further melting of the Greenland ice sheet that's already been destabilized by global warming. Scientists are concerned because the computer scenario predicts that flooding of the North Atlantic by meltwater from catastrophic melting of the Greenland ice sheet will flood the North Atlantic with cold but fresh water. Now, if you recall, I said one reason why this northern poleward transport of heat on the red ribbon here, the surface current, is so strong is because of sinking in the northern Atlantic when it becomes very saline and very dense. Now, if we flood the North Atlantic with this fresh water, it's going to shut down the conveyor belt. The water will become less saline due to mixing with the fresh water, and it will inhibit its tendency to sink. Now, the fresh and surface water is going to be less saline, and the computers predict that sinking of the North Atlantic water would be reduced by about 50%. Now, scientists also can invoke paleoclimate data. This is some paleoclimate data from a core that was taken in the North Atlantic. And this shows oxygen-18 isotopes, and oxygen-16 and oxygen-18, their ratio is a measure of ice volume. And this proxy for how much water was tied up in glaciers in the past shows that coming in from the last ice age at about 7,000 years ago, the Earth was cold with lots of ice. It warmed rapidly as it came out of the glacial stage into an interglacial, but there was a momentary return to glacial periods during this event at about, oh, I'm sorry, here's coming in, I put this wrong, coming in from the cold, about 12,000 years, another blip into the warm and then back into the cold again. This anomaly, scientists believe, was caused by melting of the Greenland ice sheet, or perhaps by getting rid of a dam on the St. Lawrence Seaway that was draining water from the North American ice sheets into the ocean. So paradoxically, what people are concerned about is that the melting of the Greenland ice sheet could lead to another ice age. So warming could actually lead to cooling. So despite the uncertainty in the climate forecast, citizens demand that their governments take action. Possibilities include dumping a tanker of oil in the western Indian Ocean to decouple the ocean from the anomalous wind stress, thereby averting or perhaps even lessening the impact of the El Nino. Alternatively, large temporary dams could be constructed across the dams or across the ice streams in Greenland and prevent the water from reaching the ocean. But the question is, are the uncertainties in these climate forecasts large enough to make no action a viable option? Or will inadvertent repercussions make the cure worse than the disease? Okay, here's my second future scenario, cure for ocean anemia. Here is the CO2 curve showing the increase in carbon dioxide in the atmosphere starting from the 1850s going up until the present. This increase of CO2 in the atmosphere is caused by the burning of fossil fuels, and this is responsible for a gradual warming of the globe. We imagine that in the business as usual scenario, this upward increase of CO2 will continue and perhaps even accelerate between now and the year 2025. As a result of this global warming, glaciers are melting, sea level is rising, and severe storms are becoming more frequent. Citizens in the year 2025 demand that their governments do something to curb the rise in greenhouse gases, but they are unwilling to give up their SUVs and other luxuries of our carbon-based economies. So, ocean research, though, has suggested a possible solution. We know right now that the oceans are the largest sink for carbon dioxide. The oceans and the plant life in them, in the process of carbon dioxide, or in process of global synthesis, takes carbon dioxide out of the upper ocean and therefore out of the atmosphere and uses it to create new organic matter. But there are some areas of the ocean that, despite having a lot of nutrients, this is a map that shows how much nutrients are in the ocean. You can see these purple patches where nutrients are low. Basically, the plant life is maxed out in that area. But there are some areas where there are an abundance of nutrients, and therefore they could fertilize more plant growth, but for some reason more plants aren't growing there. Well, scientists have now determined why it is that some of these areas of the ocean have plenty of nutrients for plants, but do not have more plants growing there, and that is, it's because they lack trace amounts of iron. And in some experiments that have been done, scientists have gone out and put in trace amounts of iron, sort of like a vitamin for plants in the ocean. And here's showing days from start of experiment. At day 0, the scientists put a slurry of dissolved iron in a patch of the ocean. And with little drifters that were built at my institution, they can monitor the growth of plants and the take-up of carbon dioxide inside the patch that was fertilized with the iron and outside the patch. And what they find is that in the area that was fertilized with the patch, carbon dioxide is drawn down, showing that iron actually can be a stimulus for plant growth in the ocean and can reduce the carbon dioxide. So scientists are quite intrigued with the idea that by adding iron to the ocean, it can reduce global warming. So now let's imagine in the year 2025, a company comes forward, and I'll call this company Maritime Carbon Creditors. This company has a bold concept which looks feasible on paper, at least feasible enough to have attracted several $billion in venture capital. The industrialized nations are eager to buy something called carbon credits. That is, evidence that they have removed carbon dioxide from the atmosphere to offset their own emissions caused by the burning of fossil fuels. But Maritime Carbon Creditors offers a cheaper alternative than the more expensive practice of recovering carbon from smokestacks or sequestering it in geologic formations. For a fee, this company, Maritime Carbon Creditors, will deploy small autonomous underwater vehicles. Here's one of them at our institute. We'll see if we can get it to go here. Yes, these small underwater vehicles that fertilize the ocean with iron and thus stimulate plant production. A second set of autonomous underwater vehicles monitors the ensuing plankton bloom caused by the fertilization. Depending on the intensity and the duration of the bloom, the purchaser, whatever country has paid for this fertilization event, is awarded a certain number of carbon credits. But the genius of the MCC plan is that the purchasers pay the total cost of the program, but for another fee, the company turns around and sells the sites of the fertilization to the fishermen, and the fishermen go in and take advantage of the stimulation in the entire food chain caused by the plankton bloom because the fish come in to feed on the plankton. So, so everyone is happy with this. The fishermen get more fish, the industrialized nations get their carbon credits, and Maritime Carbon Creditors makes a fortune. Now, while Maritime Carbon Creditors prepares to launch their first fertilization event, debate still wages among within the scientific community on the benefits of their program. But since the majority of their operations are in international waters, it's not clear that anyone would have the jurisdiction to stop them. Scientists argue that this is a win-win situation. You could mitigate global warming while increasing the productivity of the oceans. But other scientists warn that Maritime Carbon Creditors has not invested in the autonomous genetic fingerprinting technology to determine what species of plankton blooms in the ocean. For example, what if the species that blooms is this one? This is Pseudonychia australis. This is a toxic algae that produces a toxic nerve agent that can poison the food chain. If this toxic algae blooms, because the carbon credits will still be earned because there's a plankton bloom, the customer and the service provider would be satisfied in the short term, but the marine food web could be poisoned in the long term. So what can be done to ensure that their operations go as planned? If you were decision makers in the year 2025, would you allow this operation to proceed? Okay, third future scenario is called Northeast Pacific Power and Light Company. Now, in the year 2025, a large network of deep-sea cables sprawls the Juan de Fuca and Explorer plates off the west coast of North America. This is called Northeast Pacific Power and Light Company. This network was originally installed in the early part of the 21st century to supply power and communications to scientific experiments connected through fiber optic cables on the seafloor. The scientists were studying the deep sea hot springs along the spreading centers out in this area. At these sites, cooling magma erupted at the mid-ocean ridges drives a hydrothermal circulation system. These are sort of like deep sea old faithfuls, except that they are at such high pressure that they can reach temperatures of 200 or 350 degrees centigrade without boiling. Thanks to advances in technology and in understanding the longevity and the stability of these systems, the fiber optic cable network has been transformed from very basic research to a very applied purpose. Instead of energy being sent from power plants on the surface out to instruments on the seafloor, the flow of energy has been turned around, such that energy from these hot springs on the ridge crust is being sent back to shore to meet the demands of the mushrooming population along the western coast of North America. The way they do this is by putting thermocouples into these hot springs. This shows a cutaway view. And the temperature difference between the hot fluids in this part and here is 2 degrees centigrade here, 350 degrees centigrade here, there. With that kind of temperature difference over such a short interval, this process is extremely efficient, produces a lot of energy, and no waste products except for the chemical precipitates. And the chemical precipitates are in the form of iron, copper, and zinc, and they could be collected by autonomous underwater vehicles, these metals harvested, to meet the needs of raw metals. In fact, the amount of iron alone deposited by a vent field is equivalent to creating another Mesabi iron range every 250 years. Now, this deep sea power station is completely unmanned. Autonomous and remotely operated vehicles monitor the state of the ridge and supply routine maintenance for the power generation and the metal extraction processes. So the success of this Northeast Pacific Power and Light Company has prompted a number of attempts to duplicate it by other power-hungry nations. However, only a handful of countries are as fortunate as the US to have a mid-ocean ridge system within its territorial waters. So finally, we're imagining that in the year 2025, Peru becomes the first nation to invest in one of these cabled power systems in international waters by running a line all the way out to the power-rich East Pacific Rise. And they do this at great cost. But some months after operations are initiated, the Peruvians note an unexplained loss in power along their transmission line. They send autonomous underwater vehicles out to survey the line and find that an unauthorized trunk line has been run in from the cable to this little island, Easter Island, which is under the jurisdiction of Chile. The Chileans have diverted power from the Peruvian installation to meet the power needs on Easter Island, which is very poor in its own natural resources. Once they find out this has happened, the Peruvian leaders meet behind closed doors to decide how to respond. What message do they want to send the Chileans? Warships or an electric bill? Meanwhile, environmentalists raise concerns about this long-term effect of siphoning off energy from the mid-ocean ridge system. Could this ultimately bring plate tectonics to a halt? Just as we know of no examples of life in this universe that don't have liquid water, we know of no examples that don't have plate tectonics. Is the constant renewing of the surface and recycling of elements that's caused by plate tectonics a necessary condition for life on Earth? Okay, future scenario number 4. Call this icing genetic mutations. Okay, in the year 2025, the first Earth probe arrives to visit Jupiter's icy moon, Europa. Immediately upon reaching Europa, the probe deploys an instrument package which releases a chemical agent that begins to burn a hole through the icy crust of the planet. A mere 48 Earth hours later, the instrument package descends to the liquid water interface, which is thought to be tens of kilometers beneath the icy surface of the moon Europa. And that would be just in time. The intense radiation field from Jupiter is equivalent to nuclear holocaust in terms of its cosmic ray energy, and it would fry the fragile electronics in this package had it spent another day on the open surface of the moon. Upon reaching the liquid water, genetic probes immediately began to search for any forms of DNA material that might indicate life on Europa. Now, Europa is unfortunately a one-way trip. The probe can never return. But the genetic code from Europa's rugged inhabitants is beamed home by transmitters that remain on the surface and deployed from the instrument package. The reason for going to Europa is medical researchers hope that the genetic code from Europan life forms will hold the secret to reducing the incidence of cancerous mutations in terrestrial living matter. Terrestrial living matter is subjected to far lower doses of radiation than found on Europa. So after that genetic code is beamed back from Europa, here's the cover of the weekly periodical Nature. The first successful attempt to splice extraterrestrial DNA into E. coli. This prompts demonstrations outside the research facility. Who knows what processes will be mediated by that code sequence? Some people say this is worse than Jurassic Park in terms of messing with DNA. Will this result in the ultimate genetically engineered cure for cancer? Or will this be a fatal infection that ultimately destroys all terrestrial life? Okay, on to my last future scenario. Call this one RoboTuna. You laugh, this really exists. A new creature prowls the seas in the 21st century. Long humbled by nature's elegance in fitting form to function, researchers have finally built a robot tuna with all the speed and energy efficiency of its biological inspiration. The trick in this was actually designing a tail that when it shed vortices that accelerated the tuna through the water as opposed to applying drag to its body. So although the RoboTuna swims just as quickly as the real tuna, it has the one great advantage over its natural counterparts. Its brain is the highest form of artificial intelligence yet devised by man. One can think of RoboTuna as the ultimate autonomous underwater vehicle. It's smarter than the real fish, but equipped with just as many sensory perceptions and even more, and just as adapted to life in the deep sea. Now, in the year 2025, these robotic tuna will become the latest tool in the attempt to revive several important commercial fisheries that collapse in the early part of the 21st century on account of overfishing. RoboTuna are equipped with a full suite of chemosensory and acoustic devices that are used to detect the onset of spawning and track the recruitment of juveniles into the target fish populations. Now, the nose of the RoboTuna is specifically designed to mate with docking stations on the seafloor that are spread throughout the globe. When the RoboTuna return to these docking stations and mate with them, they recharge their batteries and they transmit any data they've collected on the fisheries back to shore. And they also can download satellite information that help them track the fish. So far, the information from the RoboTuna in the year 2025 will provide invaluable information for estimating the effectiveness of certain strategies for trying to revive collapsed fisheries. For some species of fish, the RoboTuna can actually act as shepherds, herding them towards the most abundant feeding grounds as determined by the satellite information relayed to the robot. Now, while there is no question that the RoboTuna have increased the efficiency and the sustainability of fish harvests from the sea, unfortunately, they will also emphasize the difference between the haves and the have-nots. The large fishing conglomerates that can afford the RoboTuna will put the family fishermen out of business. Carefully programmed RoboTuna herd fish away from the nets of the competition and in the process often destroy their fishing gear. Subsistence farming in some nations is no longer viable. Although on paper the concept of international waters still exists, it's clear that whoever owns the technology owns the oceans. So to conclude, within the next 25 years, we know that advances in artificial intelligence, in undersea platforms, and autonomous in situ sensors will allow us to command and exploit the oceans as never before. There are certainly those who will say that engineering the ocean is a bad thing, and perhaps they are right. But with current population trends, we will likely have no choice. The preceding vignettes were designed to inspire your imagination of what might be possible with technology that's currently on the horizon, but point out some of the economic, scientific, environmental, and political issues that must simultaneously be addressed. Because the oceans are global, the solutions must be global, and therein lies the difficulty. In most ways, the technology is the easy part. So by the time the students here reach the year 2025, the need will never be greater for inventors who understand and care about the sociological impacts of their discoveries, and for policymakers who understand the limitations of science and the long-term impacts of technology. As we engineer the oceans, we must be cautious in our approach, humbled by our ignorance, and farsighted in our policies. Thank you all very much. Yes, absolutely. I'd be really happy to take questions. Yes.
Do you have RoboTuna? Do you have RoboSharks too?
Well, I suppose one could ask, yeah, would we need RoboSharks to keep the RoboTuna in population balance? Actually, no one's built a RoboShark yet. In fact, the inspiration for building the RoboTuna, which of course has a very different tail design than a shark, was because tunas are one of the fastest swimmers in the ocean. Tunas can reach speeds of 40 knots or more underwater. And so, of course, there was a lot of interest in understanding the design of the skin of the fish and how it managed to shed these vortices in the process of swimming in order to try to emulate some of that to make underwater vehicles, including even U.S. Navy submarines. Much of this work was funded by the U.S. Navy, more efficient in their propulsion and faster swimming. People haven't turned to sharks for understanding that they maximize something important other than perhaps ability to go after Santa Cruz surfers. More questions? Oh, yeah, please. It's a race to the microphone. He has to climb over people. She has a farther way to go, and she wins.
How likely is a global warming scenario to occur?
Okay. All right. The problem with this is, of course, every time we do more observations, we are finding out about how more complex the coupled ocean atmospheric system is. What we can say by looking at these proxies of what climate was like in the past is that a scenario like I showed for flooding the North Atlantic with fresh water appears to have happened in the past under conditions which had similar distribution of continents and oceans, et cetera, that today, and did cause a momentary lapse in our emergence from the last ice age. To put this in perspective, you can imagine that we were going from an ice-covered Earth and in the period of to an ice-free Earth, and in the period of several generations, at the latitude of Boston, it went from ice-free to in about 60 years under 10 feet of ice year-round. Now you can imagine the havoc that that would cause to European and to European nations and to Canada in the northern part of the U.S. if the zone that was ice-free for at least part of the year only existed below about 43 degrees latitude. There would be obviously lots of farmland that would go out of production and many people that would be displaced from their homes. So it's, we can't say for sure it's going to happen, but it happened before under conditions similar to what we see now. Yes?
When you talked about the RoboTuna, you made it seem like some countries will monopolize the fishing industry, leaving others very poor and without anything to result from it. Do you think that the need for more economic stimulus or more money for some countries will override the need to feed the world?
That's a good question. I think what we're seeing right now is already a few countries monopolize the fishing in the oceans. Countries such as Japan and Norway with very large fishing fleets. U.S. has a large fishing fleet. And the problem with this is simply in capitalization. Sure, there's going to be demand from the poor countries for this, but will they have the funds to capitalize a modern fleet with modern technology. One reason why a few countries dominated is not only because there's demand for fish in those countries, but those countries have the funding to capitalize a modern fishing fleet which can outcompete the older fleets of other fishing countries. So I would say the prediction that you've just put is right on. It's already happening today, and it will probably only get worse. But I would say that attempts now to improve the technology with the way we're managing the sea, it would be a very poor idea unless we come up with better ways to manage it. And the example I'd give you is when the European settlers first came to this country, many of them, as they moved west, lived off the land. They shot buffalo, they gathered wild berries and produce, and farming and herding came in much later. Now, if you imagine that that farming and herding never came in, we were still living off the land and still shooting buffalo, and the only thing that had happened was we had developed better technology for shooting the buffalo. Instead of hitting them with the Indian bows and arrows, we're shooting them with Uzis. That's not going to increase the productivity from the oceans. All we're going to do is make more rapid the decline of the populations to extinction. So increasing the harvesting from the ocean, if it doesn't go hand in hand with increasing the bounty of the ocean, is a no-win situation. Yes?
Wow, this is great. You are good at this. I like this talk immensely. I wanted to ask, what political groups do you find the best at advocating for the ocean?
Well, where I would go to for my information is probably to the Aquaria. And I don't just say that because my institution has as a sister institution the Monterey Bay Aquarium. But it is, I think, a sane voice amidst some extreme views on both hands. On one hand, we have some of the environmental groups that would want to try to return the ocean to an absolutely pristine form. And it would be nice if it were environmentally healthy, but I don't think we have the choice of leaving the oceans alone entirely and not using them for any resources. On the other hand, we have some fishing groups that are quite sure that the cycles we see in fishing are completely natural and not at all impacted by man's activities in the ocean. And of course, the truth is somewhere in between. There probably is a possibility of having a sustainable ocean which still meets some of our needs, but it is not at the level of exploitation without investment into increasing its productivity that we have today, nor does it necessarily have to be completely hands off the ocean. And of course, many of the problems that we have with the ocean today are not just overfishing. It's increasing population along the coast and the pollution that goes in the ocean. It's all the fish traffic, the shipping traffic, oil spills. All of these contribute to problems in the ocean. Many people think that the oil spills are the worst. Actually, the non-point source pollution, just every sewer drain dumping into the ocean, puts a lot more oil in every year than from some of these highly publicized tanker accidents. So, how deep are the oceans? Well, the deepest part of the ocean is the Marianas Trench. It's 11,000 meters deep, so that's 11 kilometers deep. There have been several expeditions to the bottom of the Marianas Trench, only one of them manned, and that was Walsh and Picard, who took the submersible Trieste, I think about 50 years ago, to the bottom of the Marianas Trench. Man has not been back, but unmanned vehicles have. And what was surprising when they got there was they found that even in the bottom of the Marianas Trench, it was teeming with life.
With all the new technologies, do you think that plants will be able to produce water instead of oxygen? Maybe the whole process of photosynthesis will be like reverse, kind of? And do you know when this will take place?
Okay, you're asking, okay, plants do produce oxygen, which is good, and they do that in the upper ocean by taking up carbon dioxide. And so the question was?
Do you think scientists will be able to come up with a way that plants will be able to produce water instead of oxygen?
Oh, produce water instead of oxygen. Mm-hmm. So combine oxygen with hydrogen to make water.
Yeah, like reverse the whole process of photosynthesis.
Okay, that actually already happens. I think many of you are familiar with the technology of fuel cells, where fuel cells are a very clean source of energy because they take elemental hydrogen, they combine it with oxygen, and the waste product is water. Well, there are microbes in the sediments at the bottom of the ocean that act as biological fuel cells. And they take up, but in a symbiotic process that involves archaea and bacteria, they they combine oxygen and with hydrogen and in forming a fuel cell, and the waste product is water from that. It's amazing, if there's a chemical cycling that needs to be done, microbes have found a way to do it. It's pretty amazing. Yeah.
Hi, my question to you is, the scenario that kind of captured my imagination is the notion that there are many third world countries that lack access to fresh water systems. And it's created a huge pressure point, almost as great or greater than the access to fossil fuels for our country. And so there's a great movement underway to bring, and I hope I get the word right, desalination technology
exactly.
to these third world countries, but it has an immense cost, where it's almost the notion of water versus food, because they can't afford to pay for their agricultural and their systems, because they're under great pressure to even provide just their daily access to water systems. Okay, so then I've read where the technologies have advanced to the point where these countries are importing from very high technology countries these processes. And so my question to you is, in terms of your scenarios, so there's supposed to be then pressures on the oceans if these technologies become available at a great, to these countries. So my question is, will there be any impact on the oceans if they develop these technologies?
Okay.
Sorry it took me so long.
It's an interesting question because, and timely too, because my institute is right across the highway from a power plant, and there is a proposal right now next door to the power plant to install a desalinization plant right there. And a lot of people are very concerned about the effect it will have in the ocean. And what they're concerned about is you bring in water with 35 molar salt, which is typical seawater, but then after you extract the fresh water, the brine, which is put back in the ocean, is much more salty. So the question is, will that impact life in the ocean? And it's hard to answer because there are two things you have to know. First of all, how much fresh water are you producing? And then how distributed is your release of the brine? Now, for this plant that is proposed to go in across the street from us, we aren't too concerned about it at the level they're doing it. If you kind of disperse the plume of brine so it's not just creating one really saline glob, in one part of Monterey Bay, that might be okay. But in every place, it would have to be looked at. What are the local oceanographic conditions? How often is that area flushed? Monterey Bay actually has such strong currents and things like that Monterey Bay is flushed quite regularly by the rest of the ocean. But if you imagine some of these estuaries in a place like Bangladesh, that saline brine might stay around for a very long time and could be dangerous. One would love to see someone come up with a use for that brine, such that rather than being a waste, it can be used for something else. But again, what you'd like to see is practices in which the waste products become actually someone else's resource.
Okay. Earlier you were talking about how there's this conveyor belt system of the warm air moving upwards and the cold air moving, kind of like a system.
Right.
And you said if the sea level changed, that the whole system would stop. And I wanted to know, what effect that would have on the planet in terms of the climate and the environment if this entire, because I didn't really
Good question.
understand that part.
It's not actually simply sea level rising that causes this, but it's because as the glaciers melt, the Greenland glaciers, they put this fresh water on top of the North Atlantic. And fresh water is light. It sits on the top. The salty water is down below. If you've got this big lens of fresh water, it's not the normal water, which is salty, gets so salty that it starts to sink on its own and produces the conveyor belt. So this would sort of be like, imagine at the supermarket, the little conveyor belts that go around. Well, the conveyor belt's going around and around and around and around. Now let's suppose you glue a big piece of foam on it. When that foam gets to the part where it's supposed to go down, the foam, stops the whole thing, and it stops the conveyor belt because the foam's jamming it up. Well, that's exactly what would happen here. It would stop this conveyor belt because the dense water is not on the surface. It doesn't want to sink. And so when that happens now, we aren't pulling warm water from the equator up to the poles, and it's that warm water that keeps it ice-free. If you just looked at in a city like Chicago or New York or Boston, if you didn't have that heat transport due to the oceans, these places would not be habitable.
Thanks.
So it's a serious problem. Right by the microphone, and he can't get a word in edgewise.
Why do they focus so much on space stations and the universe?
Yeah.
Instead, they could build cities and towns and the sea and everything. And if they were to, how would they organize transportation?
Okay, lots of questions there. A lot of money is spent on space research, about 10 times as much as is spent on ocean research. Now, I would argue that I think understanding the oceans is more important than understanding space, but I would not say take money away from space research and spend it on the oceans. And the reason I say that is that it costs a lot of money to do space research. If you don't spend a lot of money on it, you don't even get off square one. So it really requires that kind of investment. In addition, if you look in the next 25 years, I would say money we spend on ocean research is probably going to be more important because that's where we're going to need the resources and that's where we're going to have the real environmental issues that are facing us short term. But 100, 200 years from now, maybe that space research will be more important. Maybe we won't solve any of these ocean problems and we're going to have to leave this planet because we mess it up irrevocably and we have to find a new one to go to. Well, if we didn't have a space program, we'd never find that planet. I am certainly a proponent for space research as well. Though I think we are underinvesting in the ocean. Now, in terms of colonies under the ocean, that could happen, but I think colonies under the ocean are probably more likely to happen for scientific reasons rather than the oceans are just a good place to live. Because of all the energy for the life support systems, I think it's cheaper to live on land. In terms of transportation, it would probably be by submarines would be the way to go. Yes? Momentary lapse of memory. It's okay.
Do you think that it's more important for us to fully realize the potential of our own planet before we start worrying about space exploration, like you were saying?
Yeah, good question. I think that this is sort of the way I'd answer your question is that we can't wait until we need space research to start investing in space research because just like a baby has to crawl before they walk and they have to walk before they run, we have such a long way to go before we can ever realize the potential of space research that we have to start now. It's sort of like at my institution where I am right now, we have some projects that we know we can complete in a year, and we know other projects are going to take 5 or 10 years to complete. If we just say, oh, well, this one we can get done right now, so let's do it, and we only worked on the year time period projects, we'd never get that 10-year one down because we never have year one of it under our belt. And so I think it is important in any kind of research portfolio that through government funding of research, that there be some short-term projects that you're investing in now because you need them now, some medium-term funding projects, which I would say would be the oceans one, because we need them in the next couple decades, and some very long-term ones that we start now because we're going to need them in the next couple hundred years.
Could you give a rough estimate on percentages of how much we have?
Okay. In terms of fishing, I think it's overtapped. Many fisheries are already collapsed. Many are at their level of sustainability, and there are only a few that are under exploited. In terms of raw materials, we've hardly touched that because just at the price of precious metals right now and basic metals, it's not cost effective to get them from the ocean, but we've only started tapping the oceans for that. So in terms of energy and materials, very underexploited. In terms of food, particularly fish, overexploited. Well, thank you all. Great questions.